All right, guys, I'm going to help you with your homework that you're doing in class today. Just right off the bat, if you go to the Kinematics playlist, so you look for Mr. Bayona in YouTube, you click on playlists and then click on the Kinematics. This video right here is going to help you with questions. Velocity, time graph, slope is acceleration. This is going to help you with questions 3 through 9. And these you want to do for homework over the weekend. This is going to be extra credit. Okay, so if you don't do it, that's fine, but it's extra credit. So I'm telling you, like, you can do it and it's worth something. All right, let's look at how to do questions real quick. All right, so you should have your notes open to do this because it's really not that hard. You're going to use the equation for acceleration. We have two equations this chapter that have acceleration, and they're going to be more, but we're starting out with a really simple definition of acceleration. Let me show you how to take this apart. This is how you want to show your work. Obviously, you don't have this paper, you're copying this down, but I want you to write out your givens. So let me go ahead and go through and circle like what's important here. All right, baseball goes from 0. Okay, that's important. What do you mean from 0? What's 0, right? This is your velocity, right? Your velocity is 0. All right, so on your paper, you want to write this out. Velocity initial, 0 meters per second to 50 meters per second. So what is that? That's a V final, right? So your V final is 50 meters per second. You want to make sure to write this out in 0.615 seconds. So seconds is a measure of what? Time. So you want to write this out. 0.165 seconds. So look, already on your homework, you get 1 point for writing all these out. So this is how I'm going to grade this stuff, okay? On your test too, this is how you're going to get graded. What is your average acceleration? So right here, what is your average acceleration? What letter represents acceleration? A, right? So my unknown is my A. So just for doing this today, you get a point for this, a point for identifying what you're looking for, right? 1, 2 points, right? Okay, now 3, we're listing our equation. And so what equation relates initial velocity, final velocity, time, and acceleration? Well, that's your new equation that you wrote for this chapter in your vocab. Average acceleration is the change in v over the change in t. Remember how we do a change in something, right? This is the v final minus the v initial. You always do final minus initial divided by t final minus t initial. And in this case, it's very easy because they gave us the change in time already. We don't need to subtract anything from this. It just gave it to us, right? Okay, so what am I plugging in the top? I'm going to do my final, which was, see, look here, connecting these two. Notice how I don't have to do any thinking. I already did all the hard work by listing this out. Okay, so here we go again. If this is moving too fast for you, go ahead and slow it down. You can reverse it. You can slow it down again. You can watch it again, but that's the point. This is for you, all right? 50 minus 0 over my change in time, 0.165. So guess what? Just for doing this right here, you got a point for putting in the equation. So here's your third point. Your fourth point for substituting in the correct things. Let me not put that there so it's not confusing. You get a fourth point right here, and guess what? Your calculator does this part. Okay, so you don't even have to guess anymore, right? So it's 50 minus 0 is 50, divided by 0.165, and we end up with 303.03, but you have to make sure to have the unit. What was it looking for? Acceleration, right? Acceleration is in meters per second squared. If you don't have that in your notes, you need to make sure you have that unit in your notes, right? So put that in your answer, meters per second squared. All right, just make sure to box it. Boom, you got your points there. Okay, so today, all you're doing for full credit is questions 1 through 3 and 11 through 19. A lot of those 11 through 19 really aren't that hard. A lot of them are multiple choice, but sometimes the vocabulary, like I said, are the hardest ones, right? Okay, 1 through 3. All right. Block is pushed with a constant horizontal force of 20 newtons against a constant horizontal friction force of 10 newtons. What is the acceleration of the block? So you can see in this question we have a few different things going on, right? So let's take this thing apart. Again, let's show all of our steps. 10 kilograms. So if we have kilograms, that is a measure of mass, right? So I want to write that out on my paper. 10 kilograms, right? These are my givens. I get a point for writing all these out, remember? Okay, with a constant horizontal force of 20 newtons against a constant horizontal friction force of 10 newtons. So 20 newtons of force. So this is force 1, 20 newtons. Force 2, 10 newtons. And how do I know it's a force? Because it's being measured in newtons. You have this in your notes, right? Force 2, 10 newtons, right? And of course, since they are opposing each other, you want to make one of these negative, okay? So we'll make this one negative because it's oppositional, okay? Oppositional friction force. Okay, you just have to pick one, right? I mean, it doesn't matter. I could have made the 20 negative if I wanted, but this would have to be positive, right? It's just like positive and negative directions, right? It doesn't really matter. You just pick one of them. I like to pick the smaller number to be the negative, just so my final answer comes out positive in this case, right? If it was left and right, you'd have to make sure to designate which one. Remember, force is a vector quantity, right? Force is vector quantity because you do care about the direction. If Julian is pushing against a cart and I'm pushing against a cart the opposite direction, it really matters which way those forces are being defined. Otherwise, I don't know which way the outcome is going to be. All right. Finally, so remember, I get a point just for writing out my givens. My second point is identifying the unknown, and usually that's when it says like what or find the, calculate the, what is the acceleration? So guess what my unknown is? My acceleration, right? So guess what? I get 2 points for identifying that. Boom, boom, 1 point, 2 point. All right, now my equation. What equation relates force, mass, and acceleration? Well, that should be your Newton's second law, right? Force net, I'm sorry, wrong. Acceleration is the result of your net forces, or the change in force, over the mass of the object, right? So how do I calculate force net? Let's move this guy over here. So how do I calculate force net? I do the summation of the forces. I add up all the forces together. Remember that one of your forces is negative because it's opposing, right? Because you're against a constant friction force, right? So what would this actually look like? You have a block. Oh, that's ugly. Okay. So I got a block here. I'm pushing it this way, and I would draw this out if I were you. 20 newtons that way, 10 newtons this way. So what's my force net if I combine these two? Well, they're opposite arrows, right? So guess what? This is how I'm going to calculate my net force. 20 newtons to the right minus 10 newtons to the left. I could have switched these two, by the way. I could have put 20 on this side and 10 on this side. It doesn't matter as long as you're consistent, right? If they're opposite, they have to subtract. So what is my net force? It's going to be 10 newtons to the right? Because that's the side that won, just like when we did vectors in the previous chapter. So my net force is going to go into here. This is 10, by the way. Sorry, it looks kind of wavy. 10 newtons here. What's my mass? My mass was 10 kilograms, right? So guess what I get? I end up with 1, and my unit is acceleration. So this has to be meter per second squared, right? All right, and that's how you do those. Okay, if you have any other questions, watch the other videos in kinematics. Like I said, the first video is going to have, that first video, velocity, time graph, slope is acceleration, is how you do 3 through 9, and that's extra credit over the weekend. All right, good luck.